Okay, so we're going to do lesson 7.4, solving problems using quadratic equations. This is the last lesson, and it's 4 word problems, and you're going to see that they come up a lot. So what you want to remember is that the key ideas is that you can write it in vertex form if they give you, for example, things that can help you for the vertex and maybe one other point. So you can write in vertex form and solve using that. Sometimes they'll also give you a right triangle, which means that you can use Pythagorean theorem. So that's where you do a squared plus b squared, and then you say equals c squared, right? So if you see a right triangle, label your sides, and then make sure that c then is your longest side, which is your hypotenuse. Also, you can see factored form. So factored form is where we have like 2 brackets multiplying. So that's like the revenue question where we have like the cost multiplied by the number of items sold. What we need to remember is that sometimes we'll have a left side and a right side of the equation, so it's going to be a little bit different. We're going to make the left side go into y1 in our calculator, and the right side of our equation is going to go into y2 in our calculator, and then we're going to press second trace number 5 in our calculator, which is called the intersection. So this whole lesson will be pretty much looking for, most of them will be looking for the intersection unless specifically we're looking for the x-intercepts, okay? Always make sure you check your answers because you want to make sure you use the answers only that are logical. Okay, so let's start with example number 1. Patricia dives from a platform that is 10 meters high. So we're going to draw this platform. So this is like a diving board. So what's going to happen is it's 10 meters off the water, and she's going to jump up 0.5 meters and then dive into the water here. Okay, so what we want to do is create a graph around this where we know our starting point is at 10 meters and she's jumping off. We know that the very bottom is 0, 0, but that's not where the graph actually ends, so we're not going to include that. So what we need is we need the vertex. 10 meters is where the diving board is, so we want to write this in vertex form. Once we have the vertex and another point, we can fill in the y equals a x minus p squared plus q equation. So we need our p and q. So that's our vertex. So we know that the person's diving off the 10-meter diving board, and it says that they reach a height of 0.5 meters above the platform. So that means they reach a height of, like we'll talk about that soon, but the time it takes is 0.32 seconds. So they're going to reach the highest height, 0.32 seconds. And what we're going to do is we're going to combine, to get this 10.5, the 10 meters platform, and we're going to combine the height of 0.5 that they jump off the diving board to get that maximum. So I added those 2 greens together to get 10.5. Okay, so once I have my vertex, I label it. P is my first coordinate and Q is my second coordinate. Then we need a point xy. So that's going to be usually the y-intercept, or sometimes it's 0, 0. In this case, it's going to be our starting point. What height do they start at when time is 0? Well, we know that they start at 10 meters off the water. That's the diving board. And that's going to occur at 0 seconds. Okay, so now that we have our x and y, we're going to start plugging these into the equation. So what I did was I replaced y with 10, a stays as it is, and then you have to add your q value, which is 10.5. Okay, so you replace everything separately. Now we're going to have to put that bracket. We're going to have to do bedmath, so bracket first and then square that value. I'm going to put 0 minus 0.32 in my calculator. I'm going to get that answer. This is the bracket. This is what's inside the bracket. Get the answer and then square that answer. Or you could have put brackets on it as well. then that's going to be 10 minus 10.5 is going to be negative 0.5. So that's still equal to a multiplied by 0.1024. Now to get a by itself, right now they're multiplying, so you have to divide both sides by 0.1024. What you do on the right, you do on the left. And then we use our calculator to calculate what that's equal to. So a is equal to, you put that into your calculator, you should get a negative value because it's downward facing. So we have negative 4.88, so using 2 decimal places is much more accurate than rounding, right? So use 2 decimal places in this one, so that's our a value. So what we need to still do is write the equation in the form y equals a needs to be replaced with negative 4.88. Then you're going to write x minus p. P is replaced with 0.32 and squared plus your q, 10.5. So this is your equation. You need this and in order to answer any question based on what they're giving you. So they want to know, how long will it take for Patricia to reach the water? So that means we're looking for where she lands in the water, which is just another name for your x-intercept. Okay, so in order to find that, we're going to have to graph this equation. We're going to have to find the accurate window and then find the x-intercept. Okay, so put this into your calculator. Negative 4.88 x minus your p-value, which was minus, you're subtracting 0.32. Close your bracket. Don't forget the squared button. So if it doesn't look like a parabola, it's because you missed that squared. Plus your 10.5, your highest height. Okay, now you have to adjust the window. Usually I start with the standard window, which is the zoom 6. So zoom 6 will take you to the standard window, and this is sufficient because you can see the x-intercept. Now we don't care about the maximum. All we care about is that one x-intercept. The other one does not matter. The other one is going to be negative, so we only want to find that x-intercept, not that one. Okay, so that one's negative, doesn't make sense. This one, the only one. So to find that, you do second trace number 2. Then what you're going to do is you're going to move your cursor until you get as close to the x-axis as possible, the x-intercept. Then you want to go to the left bound of it, which is the left side of it. Press enter. Then you want to go to the right side of it for the right bound. Press enter. And press enter again whenever it says guess. So as you can see, the x-intercept, when she lands in the water, it's going to take 1.79 if you round correctly. So that 8 has a 6 right next to it, so it has to round up. So 1.79. So we're going to write that the answer, how we found that. So we did that second trace, number 2, to find our 0, which is another name for x-intercept. Then we use the window, the standard window, to do that. So negative 10, positive 10, 1 for both the x and the y scales. And then we found the x-intercept was 1.79 seconds. So 1.79 seconds. Make sure you round correctly. Okay, so we got the answer. I highlighted it. So let's move on to example number 2. So example number 2 says 2 consecutive integers are squared. The sum of these squares is 481. What are the integers? So consecutive means numbers right after another, like 5 and 6, 10, 11, 100 and 101, right? So numbers that come right after another. So if we set the first number to x, you would have to add 1 to the first number to get to the next number. So that's why I'm going to replace them with x and x plus 1. So x is our first number, like 10. And if I add 1 to 10, I get 11. So that's that x plus 1 representation. Now what they want us to do is they want us to square both values because it says two consecutive integers are squared. So we're going to have to square the first one and the second one eventually. So what we want to do is we do want to leave it as just that x and x plus 1. So I'm going to rewrite it as x comma x plus 1. So that's our starting number. So that's how we figure it out. But what they wanted us to do is take the sum of those two squared numbers. So we're going to take the first number, square it, the second number, x plus 1, and square it as well. And it's saying that the answer is 481 because is another way of saying equals in math, right? So that's our equation. So this is a new step that you haven't learned before. But what we're going to do is we're actually going to take the left side of that equal sign, the left side of the equation, and we're going to put it in the y1 when we graph it. And then we're going to take that the 481, and we're going to put that into our y2. So the other equation part in our graphing calculator. And what's cool about this is we're going to have two equations, two colors that appear, and we have to find where they intersect. So step one is we're going to put that x squared, the left side of the equation, into y1. So this is y1 plus, in brackets, x plus 1 squared. And then, so that's the y1. And then our y2 right underneath it in the next values, in the next row, we're going to put 481. Okay. So when we do this, you'll see that if I were to use the standard window, it would be too little to actually see this because if I graph it, I only see the blue. When technically, if you graph y1, y2, you should see two colors if you have this version of a calculator because I graphed one equation in blue and one equation in red, 481, okay? So we need to adjust the window. Why 481? If we just leave it at 10, we don't see that. So we have to adjust our Y max to go higher than 481. We have to be able to see 481. So let's adjust it higher up to 500 then. So I made my window go up to 500, and then I'm going to see if that's enough to see where these two graphs meet, meaning my blue versus my red. Now, if I graph this, you'll notice that they don't match up yet because it seems to be at the side that they're meeting. Like the red doesn't meet with the blue because I need to see more of the sides. I need to see more of my x max right there and more of my x minimum there, okay, in order to see where they touch. So I'm going to adjust these values, the first ones, to be way bigger. So let's, instead of putting it to -10, put it going up to -100 and +100. So equal on both sides. So I'm allowed to have negatives in this answer because this answer said integers. Integers are positive or negative numbers, so I'm allowed to have negatives here. So we want to find where these two graphs meet, which are called intersections. So this is the window that worked. Okay, so you always want to record your window to show how you did your steps, what you did to get that answer. Okay, so I use the -100, +100, and going on forward, right? So to find your intersection, you press second trace, and our new button is number 5. Okay, so number 5. Second trace, number 5. So you're going to go as close as possible to the intersection with your cursor. Okay, so I'm going to move that little bug until I get as close as possible to it. You don't have to be that close, like close enough, that's fine, right? So that's as close as you can get to that one right there. So just press enter 3 times. So you're going to press enter, enter, enter until it says intersection and the x coordinate is your answer. So it's telling us that x is equal to -16. So that's one of our first integers. It tells us that x was our first integer of -16. Now, we need to also record the other one too. There's another intersection, so we need to find that as well. So we're going to go second trace, number 5 as well. And we're going to go to the second intersection on the other side and get as close as possible to it and press enter 3 times. So you're just repeating the steps we just did. So I did second trace, number 5, go as close as possible to the intersection, and you should find that the intersection is 15 when you press enter 3 times. Okay, so we just wrote them down. We said that x could have equaled negative 16 or x could have equaled 15. Now, that's only the first number of your integer. Remember, we have to add 1 to get to the second number. So if I take negative 16 and add 1, I get negative 15. So those are my two numbers, negative 16 and negative 15. And same thing for 15. If I add 1 to it, so if I take 15 and I add 1 to it, that's going to get me my next number. So 15 plus 1 equals 16. So my next number consecutive would be 15, 16. Okay, so if you look at the numbers, negative 15, negative 16 are consecutive. That's one set that works, and 15, 16 are also consecutive. Okay, so what we're going to do is check in our calculator. So I want to show that when you square those two answers and add them together, you should get 481. That's what we're trying to prove here. So I'm going to take 15 squared, because it says square your first number, square your second number, 16, and it should equal 481, which it does. So that's why it works. Now I do the same thing for the negatives. Negative 16 squared plus negative 15 squared. So that also will give you 481. So as you can see, they both work. So that's why we had to come up with two sets of solutions. So consecutive means one after the other. Okay. So that's example number 2. Let's go on to example number 3. So what we want to do is we want to create a portrait. He wants to be a square, so I'm drawing a square here. And he's going to create a mat around it. So a mat is like that fancy kind of border that's going to go around it. And what we need to, what it's telling us is that it's going to be 7 meters or 7 centimeters wide. So on every single side, we're going to write that it's 7 centimeters wide. So that's the width of that little kind of border around it. So what we're going to want to do is they're going to ask us what are the dimensions of the portrait. So that kind of pink picture is what we don't know. So what we want to do is we want to remember that the area of the mat should be equal to the area of the portrait itself. So that inside piece is going to be equal to the outside piece, right? So remember, if we take the whole area and subtract the picture, we're going to get the border. Okay, so the border is equal to the picture. So the picture is going to be x times x. We don't know what that portrait is going to be, so we label it with this unknown x. So since it's a square, both sides are both x's. So we want to take the total area minus the picture area, and that will equal the picture, because the total area minus the picture will give us the border, and the border should be equal to the area of the picture. So that's what this is trying to represent, that second sentence. Now, the area of the total, we have to find that. We have to figure out what the side length of one of these is, one of these sides is of the square. Now, we know that x is that picture, right? Okay, so x is the picture, and what's happening is we have 7 being added on one side and 7 being added on the other side. So we're going to add 7 and 7 to go all the way across that side length. Okay, so it's going to be x plus 7 plus 7. Now, if you simplify that, you should find that x plus 7 plus 7, you can add those two 7s together. So that's going to be equal to x plus 14 instead. Now, since it's a square, both sides are going to be equal, right? So the length is going to be the same as the width in this kind of situation. So we can just write x plus 14 squared instead of writing it twice. So that only works with if it's a square. Now we have to do the area of the picture. The picture is that pink. So we know that one side's x, the other side's x, x times x is x squared. And the area of the picture is equal to also x squared. So they're saying whole picture minus picture gives you border, and the border is equal to the area of the picture. So that's what the equation is. So what we want to do now is we want to label the left side as y1 in our equation. This is going to go into our calculators. And the right side of the equation is going to be labeled as y2. So we need to find where these two parts intersect. So this is where we switch to the graphing calculator. Okay, so watch my little typo here when I'm putting it in. So you have to be careful. So clear everything in your calculator and you should be putting in that x plus 1 squared, or sorry, x plus 14 squared. So that's your area of the entire picture minus the area of the picture. So you'll notice I just put x, but it should be minus x squared. X squared. Okay, so I'm just going to get to that part over here. So I fix my error. So this is where it's fixed. So now I'm going x plus 14 squared minus minus x squared, and that's equal to x. So I kept the same window as the previous question as like negative 100, positive 100 going up, and then my y max I changed to 500 because I was adjusting it. I started off as like I think 100 and I kept increasing it until I saw the intersection. So as you can see, this first intersection is negative, so it doesn't matter. This is the one I actually want to solve for. Okay, so I want to find this intersection here. So make sure that your y1 looks like this, your y2 looks like this. This is the left side, right side. Then we're going to go to the window. Okay, so this is our window that I used. I went from negative 100 to positive 100. My y minimum was still negative 10, but I went up to 5,000. I could have actually gone less than 5,000. It doesn't have to be that high, but this was enough to see the intersection. Now, the intersection I need has to be positive. You can't have a negative x value here because x represents the picture frame. You can't have a negative length of a picture. So it doesn't make sense to have negative values in this situation here. Okay, so I wrote down the window, x negative 100, positive 100 going up by 1, negative 10 going up to 5,000 going up by 1. So let's find that intersection. So we're going to do second trace number 5. Move your cursor as close as possible to the intersection. I only want that intersection because it's a positive x. So now you just, when you're as close as possible, press enter 3 times. So I did second trace number 5, enter, enter, enter when you're close to the intersection. You should get 33.8. Okay, so 33.8. This is going to be the length of your picture, which makes sense. The other one would have been negative, which would not make sense. Okay, so 33.8 centimeters. Okay, so I'm just showing my steps. I went second trace number 5. Then I found that the intersection was 33.8, write the centimeters. And then we want to label our dimensions. So as you can see, one side's 33.8 and so is the other side of your square. Excuse me. So that is that's just one of your side lengths, but they say what should the dimensions of the portrait be to the nearest tenth of a centimeter. So that's where we want to write length times width. So our final step is to write dimensions. So the dimensions are your length times your width. So my length was 33.8 because it's a square, times your width is also 33.8 centimeters. So that answers your question. Our last example, example number 4, we have a right triangle now. So remember how I was saying at the beginning that if you have a right triangle, you're going to have to do Pythagorean theorem. So what I'll do is I'll start by drawing a right triangle, which has a 90-degree angle in that bottom left corner. And we can label it with like A, B, C, C being your hypotenuse.
So what we need to remember is that Pythagorean theorem is always a squared plus b squared equals c squared. And then they also give us perimeter. Perimeter is if we were to add up all the sides together. So a plus b plus c equals 130 centimeters. So one side of the triangle is 43 centimeters. So we can pick which side we want 43 to be. It doesn't tell us it's the longest side, so I'm going to assume that it can only be A or B. So you're going to replace everywhere you see a B with 43. And then you want to solve for one of your variables. You have a choice to either solve for A or C. So to do that, we have to use that equation and subtract 43 and bring it to the other side first to get one of those variables alone. So if I use my calculator, I find that A plus C equals 87. So I just had 130, I put 130 in my calculator minus 43 to get that. Now we're going to solve for A. So we're going to bring that C to the other side. So it's going to be 87. If it's positive on the left, it became negative on the right? So I moved it over to become 87, take away C. Once you know what one of your variable is, that's what you want to use to replace it. So everywhere you see an A, replace it with 87 minus C in Pythagorean theorem. So A was replaced with 87 minus C squared. Then you have B, we know is 43, so put 43 in the spot of B. And C squared can stay as it is, so it should be squared. So make sure you put a little 2 there when you're doing this. So it's going to be 87 minus x squared plus 43 squared equals x squared. So we need to remember that we're going to use x's in our calculator, so don't forget that little 2 there. You'll see I'll put it eventually. So when I do write in my equation, I put the left side into y1, the right side into y2. Okay, so this is the left side going to y1. So I put the left side of the equation, which is your a squared plus b squared equals, and now the right side of your equation is going to go into y2. So the right side of my equation is supposed to be x squared. Remember, x squared. So as you can see, I put that little 2 in it at the end. Make sure you do that in your notes as well. Okay, so that's my y2. y2 is x squared. So I'm going to keep the same window as before, as my previous question, to see if that works. Usually for these word problems, you'll see that the numbers are quite large. So for the y max, usually set it to a large number, and you can always like play around with it. So I'm using the same window as the previous question, and I graph it. And this here works because I see this nice positive intersection right there, which tells me that that one looks good, right? It makes sense that it's positive. We're not going to have a length of a triangle being negative. So we need to find that intersection. This is the window that I used. I did the same window as the previous question, negative 100, positive 101, negative 10, positive 5,000, up to 1. Okay, so then go back to your graph. We wrote down the window, so this is me writing down the window here. And I did second trace number 5. Go to the intersection as close as possible to it. So sometimes you'll have to like restart it if you don't see the little bug, that little cursor. But if you just press like second trace, enter, 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 like enter, 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 even if you don't see the bug, usually it does take you to the right location. But in this case, when I redid it, it did work. Like if I did second trace, so I'll just like fast forward a little bit. So there's my bug. When I redid it and I did second trace number 5 intersection, press enter 3 times, it gave me this intersection, 54. It does want all your side lengths to the nearest centimeter in the question. So you have to make sure you round to whole numbers only for this situation. Okay, so keep your number as 54. Okay, so I wrote that x is equal to 54. That's what I just found. And that's my c because x is c. So c is equal to 54. That's the longest length, and that makes sense right there because it's longer than this side so far. Now you're going to use this equation, which is the a equals 87 minus c, to solve for a because we know what c is. C is 54. So replace c with 54, which we just found. Use your calculator, and you should find that it's 33 centimeters. Okay, so now we can label 33 centimeters for A. Okay, so don't forget to include the units. So we have our two missing lengths, well, our three lengths. So we know that one side was 43 because that was given. The hypotenuse, the longest side, is 54, which makes sense. So if this wasn't the longest side, I'd be worried. And then this last one, this A value is 33 centimeters. Okay, so don't forget those units. Okay, so that's it for example number 4. These ones are practice that you're going to want to work on over the weekend and get as much practice as possible. So this first question is just like that first parabola question that we did where you're drawing the parabola. So it matches up to that first one we did. Let me fast forward a little bit. There you are. Okay, so the first question matches like the very first question we did for this lesson, which is where you have the parabola. So I'm just pointing out that's this question for example number 1. The second one is where you look at the consecutive numbers. So the x and then x plus 1 kind of question. So that was the same that matched our question, right? So we have a question like that too. And then number 3 is that right triangle perimeter one. So the one we just did. And then it goes into question number 4. So question number 4, they're giving you the equation and they want us to determine the x-intercepts. So that's because they're saying how far are these two towers. So we're assuming the towers are going to be at the bottom of the structure. So find your two x-intercepts and the hint is subtract them. Take your bigger x-intercept, subtract your smaller one, and that's how you can find out the distance between them. Your next question matches that like picture one. Francine is an artist. That's that matte picture one. So the only difference is this one's not a square. Okay, this one's a rectangle that you're working with. And the last one is where you use that revenue equals cost and number of items kind of situation, right? So we've done a few questions like this. So it's two brackets. One's the cost bracket, one's your number of items bracket. The only difference is now revenue is going to be replaced with 1,562.50, like $1,560.50. And then you're going to write your money bracket, your number of items bracket. So don't forget that you're going to put the left side into y1, the right side of the equation into y2, and you're just finding where they intersect to find the answer versus what we did before. Usually in the past we always looked at that maximum, but in this case we're looking at where these two things intersect, and that can help you find the x, and then you use the money bracket to find the ticket price. Don't forget that these are your answers, so check your answers at the very bottom. Okay. At the very end of this lesson, I'm just going to scroll up. You do want to practice those few questions in the homework. Hopefully you guys aren't getting dizzy. Keep going, keep going. I'm just moving to the very, very, very beginning pages of your booklet right here. So this is where you want to go back to and make sure you do your day 12 homework 7.4. So as you can see, there's 5 questions that you're responsible for to get that stamp, and I'll just stamp this after your Easter break or when we return. So you'll just have to show me them when you return. So these 5 questions, make sure you get them done. So that would be it, guys. That would be it. Okay, so make sure you ask questions if you're not sure, but you got to practice. You got to practice in the homework, and you got to practice with those last remaining things. Homework questions and then those questions at the very end. Those ones will help you prepare. So you're going to get a question or 2 on your test that are similar to those. You just don't know which ones you're going to get. So make sure you practice, okay? Enjoy your day. I hope to talk to you soon. Talk to me if you guys need help, okay?